All right. And now today in labor economics, we want to look at the demand for labor. I do welcome you to this conversation. So I actually brought in the questions. You know, be very fast. Instead, I will take time to you have the proper and detailed understanding of these concepts. Why should you have the detailed understanding of these? Because you're going to use them. We're going to use them as we are going to be answering the questions, yeah? So we'll be answering the questions very soon, probably in this same lecture. But before we answer the questions, I see it necessary that we go through these concepts. And once you understand the okay. So now, it's a demand for labor. It is said to be a derived demand. Why do we say it is a derived? Listen carefully. Because labor on its own, by labor we are referring to the efforts of the human resource, engaging their power, their natural abilities in acquiring, resources or in acquiring income. That is what we mean by labor. Yeah. So labor refers to the human effort, engaging their abilities, their faculties, and in acquiring income. That's labor. So now we say that this labor has the demand frequently, usually in these exams, is to explain why the demand of labor, the demand for labor is said to be derived.
You are breaking.
I'm here.
You are breaking.
The line is cutting. Is it the same with everybody? Hello?
You are breaking, sir.
Is it cutting with everybody?
I don't know if it's just me or
anyone
else is experiencing the same thing.
Hello?
I think the network is just bad today.
Oh, it's cutting. Is it still cutting?
You are clear now.
Okay. How is it now? Is there an improvement? Hello, is there any change? Any improvement? Hello? Anyone to confirm? Are we good? Is there any? Oh, okay. Thank you for the confirmation. So I said that mostly you will meet this question asking you to explain why the demand for labor is said to be derived demand. Now, the demand for labor is a derived demand because it gets its value from the demand of the commodity that labor is used for. You have not gotten this one. Let me repeat. The demand for labor, it is gotten from the demand, or is determined by the demand of the commodity, right? The commodity that the labor is used for. The labor is used for. I do repeat, the demand for labor, colleagues, is determined by the demand of the commodity that labor, that particular labor is used for. Okay, So when people are working, for example, you are producing something, eh? You're producing a certain product. The question of the day is, how is the demand of that particular product, that you are producing using that labor of yours? All right. If that commodity is on high demand, truly the demand for your labor, right, shall be on high demand. So you'll find that if the commodity that particular type of labor produces, is on high demand, then that particular, type of labor will be on high demand and vice versa. Are we good? Have you known the meaning of derived demand for labor? I'm trying to take my time, make sure you understand, then we move on. So we say the demand for labor is derived. Why? Because it is basically determined by the value of the commodity that the labor is used for. Okay. I think I've already scored that point. We said, again, I repeat, it is derived from the demand for the product or the service that the labor is helping to produce. And so, for example, the demand for hamburgers will lead to the demand for hamburger workers, like a lot of those workers. Then the demand for the workers, therefore, shall depend on how productive the workers are and the price of the product the workers are helping to produce. The same concepts that we learned that demand of a commodity or of a service or a product is influenced by the price of the commodity. The price, of the commodity influences the demand for the commodity. Listen carefully. Since the price of the commodity influences the demand for the commodity, it entails that even the demand of the labor or the workers that are helping to produce that particular commodity shall be affected in the similar manner. So if the price of the product therefore increases, all right, let's say the price of the product the workers are helping to produce, increases, then the question of the day is, how will be the demand for that particular product? You get the point? Then you will see many people being employed, okay? If the price of the product, let's say the price of the product changes, it impacts the demand. And so when that demand is impacted, is affected, then that same demand will affect the demand for that particular labor. So the potential exam question that you could have is to explain, factors influencing the demand for labor. Your question is, what factors, determine the demand of labor? At this point, we don't want you to start, we don't expect you to start listing the price, the other factors that affect the general common demand of a product. There are specific factors affecting demand for labor, being, for example, how productive the workers themselves are, and the price of the product the workers are producing. These are potential exam questions, and you need to pick these answers. What factors affect the demand for the workers? Is there any question? I've said the price and also the productivity. Okay? Maybe I want to ask a question to the, how does helping to produce affect demand of workers? Are you able to justify this? Are we good? Are you all able to hear me? Or I'm logged out now already. How does the product, the price of the products, the workers are producing help influence the demand for those workers? Okay. Okay, confirm you are able to hear me clearly. Just confirm you are able to hear me.
The network is quite bad today. We've missed a lot of things.
The issue is that I expect people to comment and we remain so quiet. I'm forced to just move on when I'm explaining because people don't say anything. I don't know if you're following, whether I'm breaking or the line is cutting. So it is extremely important, colleagues, that when I'm presenting, for example, like you should give feedback. Get what I mean? Yeah. If you're in that position, just give that feedback and then we move on. Okay, is there any improvement now? Are there people confirming the improvement in terms of the network? Hello?
You're clear now.
Okay. Thank you very much. So let's look at the firm's short-run production function. Now, to start with, when you hear this word short-run, it does not really specifically imply to a period of time. Like maybe, let's say by short, we mean 5 days or 2 hours. No. Are you paying attention? You're following this, right? By short run, mainly how it is used in economics, we refer to the period, of course, when specifically the factor of production, not just the mere period, like time, like 100 years or what. No, basically any time when you have one factor of production fixed. You have not gotten this one. Okay. Here, when one factor, when at least, let's use the word at least, when at least one factor of production is fixed. All right. When at least one factor of production is what is fixed. And what we mean by this time around by factors of production, this could include the capital. By capital, we are referring to machines, land and all those. Then we're saying capital, assuming that we just have two forms of land of versus of inputs or factors of production, capital and labor, right? So capital, other fixed assets, and labor. So when any of these is fixed, mainly capital, when you are still using your capital, your assets fixed, then maybe labor at that point is varying, then that period is said to be a short run. You have not gotten this one. Let me repeat this. We are saying a short run period. When you say this is short run, we're just trying to say that at least one factor of production is fixed, where other variables a variable, all right? They're changing. For example, you have not gotten this one. An example will do better. Listen to the example. Before I give an example, am I clear up to now, or the line is already cutting? Hello?
You are
Is there any
clear.
improvement? Are we good?
Yes, you are clear.
Oh, okay, thanks for that response. Now listen. Let's say you are a farmer, all right? You are a farmer and you have this piece of land. This piece of land is 25 hectares, all right? And how many workers do you have? That's labor now. The land itself is a fixed asset and you're producing whatever you're producing, right? So when you start, maybe you start with 10 workers. The land is still the same. After some time, you employ some more workers, you're 15. The land is still the same. Are you saying that labor in the fixed one? You increase the workers to 30, but land is still what? The same. This period where this asset or this factor of production, the capital one, is still fixed. Regardless of how long it is, like in terms of mentioning maybe 1 year or 3 years, it is still a short run. So short run does not really, it's not really,
You're breaking, sir.
it's when factors of production, right? Thank you for that response. Network is giving you a chance. Okay, is there any change now? Hello? Are we good?
I can hear you now.
Hello? Okay, you can hear us now. All right. So I was saying that it can be 10 years, but as long as one factor of production is fixed, it is still short run. It can be 100 years, as long as the other factor of production is still fixed, like maybe you're still using the same land, according to the example that I gave, it is still the short run. You get what I mean, eh? That is still the short run, okay? So it can be just 1 week. In 1 week, you can change maybe land again, you vary land, you get some more land. Then at that point, the two factors of production have changed. You've changed, also changed the labor. You've employed more workers. Then that period is no longer the short run. That becomes long run. Get it, eh? So in the long run means that from the initial point, have all factors of production changed. If all the factors of production have changed, then that is the long run period. Is that clear? But if only one, at least one of them is still fixed, that is still long run. That is still short run. Are we good? Can you hear me again? I'll keep on asking because this network is not dependable. Are we good? Can you hear me again? I'll give you another example.
Yes, I can hear
Everybody
you.
get it.
We have a machine. Let's get a machine now. This machinery, the machine is being operated by only one person, right? Let's say, okay, let me give you an example of a barber shop. You have one barbing machine. You start one barberman, one barbing machine, right? One machine and the one unit of labor. That is in the short run, right? In the long run, you adjust. You have maybe two barbermen, two people barbing, but using the same machine. You've employed two people. You get like when this one is tired, the other one. That is still the short. You get the 3 more machines. You also add the more people. That now becomes the long run. Because all the factors of production have changed, the labor part and also the capital part. You have gotten that one. Or if the barber person is still one, like the barber man. Nowadays, we even have barber women. Eh? It's not just barber man. There are some women that now want to touch people in their heads and cut hair for the men and for everyone. Okay. So those are barber women. If you could have this one barber woman, and they are using maybe 2 machines, they bought more machines in their business. As long as the one unit, labor is still fixed, the capital part has varied. That is still a short run because at least the one factor of production is still what? Fixed. Then the other one is variable. I think I've taken time to interpret and explain to us what we mean by short run and long run. Any question? I'm taking my time because these concepts are very important for you to help you answer that question.
You are cutting.
So now it draws a relationship now between the line okay. I am back now. Kindly confirm with that movement. Can you see the screen and can you hear me? Hello? Yes. The way how Zephyr has summarized it, that is it. In the long run, all factors of production are variable. That's what we're saying. But in the short run, at least the one. Yeah, it can be one or more. At least as long as there is only one factor of production that is not variable. That is short run. Okay. Now, hello, are you able to hear me now?
Yes.
Yes.
Oh, okay. The production function, therefore, shows the relationship between the inputs and the outputs, right? The output is basically what has been produced. Then the input is what you inject, what you put in to produce whatever you're producing. Okay, that is what we mean by the output. So now the production function, it basically is there to show us that relationship. It says that total product, which is basically the output, shall be determined, or it shall be a function of capital and what? And labor. That is to say, it shall be determined by capital and labor. In other words, total product will be influenced by the capital and labor. At this point, we are just assuming we only have two, forms of labor. We just have capital and forms of inputs. I just have capital and labor. So this is what the production function means, just expressing the mathematical relationship. And now at this point, we have already said that in the short run, at least one input is what is fixed. Then this is what we have. We can have, for example, capital being fixed in this total function, as you can see this function. Then labor gets to be variable. Then we will have the following, and we need to define. The total product is basically the total, output produced by each combination of labor and a fixed amount of capital. Remember, this is the total product, the output. It is as a result of those units that you have combined. Function, meaning as a result of, or is influenced by. Remember, capital is fixed, then labor is varying at this point. This is in the short run. So it's about maybe on a piece of land, which is fixed capital. The output that you produce will be dependent on how many people, that's labor, you have employed on this fixed piece of land. That is what total product means. Is that clear? So in other words, I've just used the common example that we can easily relate with the land and the labor P1. So the total product produced shall be that combination that you can really, have. For example, for maybe each hectare, you say each hectare, or each acre, you need only 2 acres. That is the combination you're putting. Or you could say each acre, you need 5 workers. That's 5 units of labor. So that combination, when you have these people now, you have the land, you have the people working, combining these inputs together, they can vary other inputs, put them together, then you produce whatever you produce. Whatever you produce is what you call total product. Okay. Marginal product, therefore, shall be the change in the total product associated with the additional unit of labor. So you see, since the capital is fixed, now when labor changes, for example, you increase labor, you employ 1 more person, you will see that the total product will increase, right? May increase. Now, when it increases or it changes, that specific change in the total product because of the change in the unit of labor is what you call marginal product, right? That is marginal product. Then average product, therefore, is the total product that you have produced. Basically, total product divided by output or divided by the units of labor. This will be average product of labor, But if you have this average product of labor, then you are good. Basically, yeah, it is that average product is the total product divided by the inputs. We also have average product of capital. Average product of capital. This one is the total product capital, or the rate that is associated with the change of capital now. So total product has changed as a result of the change in total product as a result of the change in capital. Basically, that is average divided by versus total product divided by capital. Yeah, that's the average product capital of the labor. Okay. Now we can see graphically and can see this basic graph, right? And as fixed unit, what you're going to observe is that the total product will be increasing It has started cutting again. Okay, just a minute. It's fine. It's fine. Just a minute. Confirm you can hear me again. Can you hear me?
Yes, I can hear you.
Okay, now that's fine. Let me continue then. So I was saying that the first, when you have, for example, whatever units of labor that you do have, right? Whatever units of labor that you have, you keep on increasing the total product. Then what will happen is that this marginal product, the unit change will be increasing at a first point up to just a certain point. But after a certain point, it will start to decline. You have not heard this one. Let me put it like this. Look, one factor of production is fixed, right? That's land in our case. Imagine you keep on employing the same people, adding to them to the same piece of land, right? Same people are being added to the same piece of land. At the very first time, you employ 2 people to this maybe 2-acre piece of land. The product or the produce that they produce will increase, right? Will start increasing. Like initially you get what's this? 2 people, then you add 3 more, it become 5. You see that the output will increase, right? It will increase because you've increased the people working. All right, it will be increasing. The output will be increasing at an increasing rate, right? But after a certain time, if you keep on adding labor to this fixed piece of land, let's say you have what do you have? You have 7. You add 7 more people, you have 25 people. How can you have 25 people just work on 2-acre land? At that point, you will see that the total product started declining now because there has been too much of, variable capital, variable, input being employed and added to this fixed unit of input. Did you get that one? So at first, as you employ more people, the output is increasing at an increasing rate. Then it will start slow. Like the total output will be increasing now at a very slow rate because the people are now 2 men on a fixed piece of land. Like they're working on a very small piece of land. They have nowhere to step, They're just too many people. So if you want people to be much more productive, at least just employ enough. That's the message we are sending. It will start increasing at a decreasing, right? Then afterwards, it can even start falling, right? So now what I'm trying to explain is what we call the law of diminishing returns, all right? This is called the law of returns states that is changing,
You are breaking, sir.
then it will rate, and finally starting?
Yes,
Hello?
we couldn't even hear you, person. Hello?
Even now, you can't hear me. Hello?
You are breaking,
Hello? Do you hear me?
but you are still breaking.
Okay. Just a minute. How is it now?
Try
How is
again, you are breaking.
Okay. Anyway, the line was static too much, and can you hear me now again? Hello? Any change? Is there any small change?
Yes, we can hear you.
No, okay, thank you. So I was explaining the law of diminishing returns and explained that as you keep adding, a variable input to a fixed input, then the total product will increase to start with at an increasing rate, then it will decrease. Yeah, it will do that at a declining rate. That's what the law of diminishing returns mean. So I tried to explain that. You even see that the curve, for example, this one for the total product curve is small, indicating that labor can be increasing by amounts of less than a single unit. In a continuous function, for example, you can have labor is increasing by less than one, like by small units, right? This is the representation that we are giving. Yeah. So now, if you are given, for example, the list showing you the marginal, the total product, how do you find the marginal product and average product? Listen carefully. To find the marginal product, I've said it is the change in the total product divided by the change in the output, like the units. You get it, right? So for example, when the total product is still zero, then the marginal product will be zero as well. Then you start from the second unit, from the first unit. From the first unit, total product is 8. So the change in the total product will be 8 minus the previous unit is 0. You get what I mean? Eh? Total product 1, TP2 minus TP1 divided by Q2 minus Q1. That's that. So total product 2, that's the 8 minus the previous one is 0. So 8 minus 0 is 8, yeah? To be divided by 1 minus 0. The output here is 1 minus 0. That will give you 1. Divide all that, you have 8. Therefore, the marginal product shall be what? Shall be 8 at unit 1. Is that clear? Have you gotten that one? You have not gotten it. Let me repeat.
You start from the formula.
Let me
The
start
one you
from the
said
formula.
the total product
So
divided by
total product 2, or a higher total product, minus the total product 1, or a lower total product, divided by output. This is these units, 2 minus the out 1. In other words, a higher total product minus a lower total product divided by higher output divided by, minus the lower output. So what you're saying here is when the output is 0, then it means that even the marginal product shall always be 0. So you have 0 here. Now, let's find the marginal product mathematically. You say total product 2, which means a higher one. So in this case, the higher one starting from 1. So say 8 minus 0, the previous one, right? To be divided by the units as well. Here you say 1 minus 0. This will give you 8. So the marginal product is 8 for 1. When you come here, it will be 20 minus the previous one is 8. Divided by the units are 2 minus 1. This will give you what? 12, yeah? Isn't it? Marginal product will be 12.
yes.
I guess the class is following. Then you say 34 minus 20, that's 14, divided by 3 minus 2, that will give you 14, right? And then 46 minus 34. 46 minus 34 is what? Forty-six minus 34 is what?
Is it not
You said
12?
46 minus 34. So
Is 12. Then 56 minus 46, that's 10. And the 64 minus 56,
64 minus which one? 56.
56.
It's 8.
Is 8. Yes, 70 minus that is 6. This is 4. This is 1. Then in 73 minus 75, it even becomes to negative, right? Now, what have you observed about the marginal product? How does it move? Have you seen that it increases? After increasing, it starts declining, right?
Yeah.
It increases up to somewhere unit 3, where we have 14. After unit 3 is a maximum. Then after unit 3, it starts what? Declining. It declines up to unit 9. Then beyond unit 9, you even have a negative one. At unit 10, you have a negative marginal product. So that's how this is done. So now let me just interpret what marginal product. It means that the additional value of that input decline. It starts by increasing. For example, when you are employing more, the more people you employ, the units are increasing up to 3, right? Just up to 3. Then after 3, we want to graph this. How does it go? After 3, it starts declining. And after 10, it goes to the negative. Have you seen that? This is the marginal product. Are we good? Are the people following the graph? It increases, then it declines until it becomes negative. It's negative from here. These are negatives going down. Meanwhile, the average product, it goes there. Now, one science that you should learn is that when the marginal product becomes, when the total product reaches at its maximum, the apex, this point, at that point, marginal product will be exactly equal to 0. You get the point, eh? At the unit, that's why you've seen, at the unit between 9 and 10 here, marginal product is almost 0. There is 1 here, positive 1, then it goes to negative. There is a 0 in between. So get that message, please. I'm explaining the relationship. So the relationship is that when total product is at maximum, then marginal product is equal to 0. Okay? These are important points to take home. Marginal product equal to 0, then total product is equal to what? Is maximum. Or it reaches the turning point. You get the point, right? When it reaches its apex, the highest point, where it can no longer increase, from there it starts to decline. Are you following the relationship? Marginal product will be equal to 0. Then when the marginal product becomes negative, right? Then total product starts what? Falling. Have you seen that? When, as long as the marginal product becomes negative, right? Then you see the total product starts what? Total product here has started, the curve for total product has started falling, like that's why it has bent down. Are we there? I want you to understand the slides. Are we good? Do we have a question? Can you see the screen?
Yes, I can see. May you just explain again the last points you?
Yes, we say that
You're just
when marginal products becomes negative, all right, total product starts falling. At the point when marginal product is negative, then total product is falling. You get the point? It is declining. It had reached as far as 75. You've seen it. Then it has fallen now to 73. That's what happens. Have you seen? Total product, you can even read it from mathematics here. Mathematically, you can see it from here, right? You can see it from here. The maximum is between what? Somewhere here, between units 9 and 10. 75. From 75, again, it goes to 0. It was increasing all the way. Total product is increasing, total product is increasing. Up to the point where marginal product was the 0, then it started falling now. You have 73 going down. Are you seeing that? So in other words, to simplify it, we are saying when the marginal product is negative, then total product is falling. You get it, right?
Yes.
And when the marginal product is 0, then total product is at its maximum. It reaches the maximum. What about when total product, when marginal product is increasing? When marginal product is increasing, listen, when marginal product is still increasing, then at that point, total product is still increasing as well. Marginal product is increasing, the total product is increasing in the first stage. These are stages that we have. The first stage where marginal product is increasing, then it starts becoming what? Decreasing, then it becomes negative. These are stages. So this is the first stage, this is the second stage, and this is the last stage, the third stage of production. So in the first stage of production, both marginal product and total product, they are increasing, right? Isn't it? You can see this graph, right?
Yes.
Marginal product and total product, they are increasing in the first stage. Second stage, what is happening in the second stage now? Total product is increasing, but marginal product is falling. I think that marginal product is decreasing, it's here, but the total product is still increasing. Then in the third stage, marginal product becomes negative and the total product is falling. Are we good? There is quite a lot that we have learned about this graph. I've said a lot of things you need to remember. Very important. Let's talk about average product. How do you find average product? I said you say total product divided by what? By output, isn't it? Total product is 0 divided by output 0 is 0, right? Then the second one will be total product is what? 8, right? Divided by output 1 is still 8. Are you following? Then total product is 20, output is 2. This will give us 10. And then total product is 34 divided by 3. What does it give us? It gives us 11 point something, right? Are you dividing? Like if 3 into 34, this should be 11 something. Then 4 into 46, this should be 12 point something. You're following what is happening, right? You're just dividing
That's
total
4
product.
divided by what? 46.
Total products divided by output. So now you say 5 into 56. What is 5 into 56?
11.2.
11. It starts declining now. Have you seen that? Exactly. When this one, marginal product has started falling, it started falling at as early as at unit 3. But the average product started falling when? At unit somewhere around unit 5. 7 into this into 70, that's 10. So it will be falling as well, even this will be falling and falling. Until it become 9 into 7, 5. That's how many times? That's almost 7 something. Okay. So even yes. So now let me draw the marginal product, not the marginal product, the average product curve using a green mark, if you are fine with it. When does it stop increasing? At what unit? At unit number 5. It is increasing up to unit number 5. You've seen it? Up to unit number 5. After unit number 5, what happens? It starts falling. But as it is falling, you know what happens? This is what is interesting about it. It will never become negative. Have you seen it? It will just become asymptotic around the vertical axis, right? The horizontal axis. It doesn't cross to go to the negatives like the marginal product. Are you getting that science? It will just, to be asymptotic, it will just be more like touching the x-axis, but it will never touch the x-axis. It will just go like that. That's the message. This is the average product. Any questions? Hello? Do we have any question? Okay. Now that we are good, okay, don't worry, we're about to conclude, don't worry. I just wanted you to understand this relationship, both mathematically here and the graphical. This is what we mean by understanding this. It means now you understand this. So there are all these quantifications. I think we already did them together. Okay. The drawing, you've seen? This we already did it together. Average product never becomes negative. But marginal product can go up to negatives. This is the relationship. Total product is increasing, and this is the relationship put together. Yeah. So you've seen the stages, right? The stages are here. These are the 3 stages that you have. First stage, up to 3, somewhere there. Second stage, between 3 up to somewhere 7. And the last stage. So the first stage, there is what you call increasing returns to scale. At that point, the additions to labor increases efficiency of labor and efficiency of capital. So that is what you mean by increasing returns to scale. Then the second zone has what you call a constant returns to scale. Okay? During the zone of production, the second stage actually, you have constant returns to scale. At that point, you have just a very efficient combination of labor and capital equal. But finally, in stage number 3, you have diminishing returns, like decreasing returns to scale. At the point when you have decreasing returns to scale, then additions of labor will reduce the efficiency of labor. This is what I was telling you. You add more people until the people stops being efficient because there are too many at the same working place. So this is the interpretation. I've already said first stage is what? See? Increasing returns to scale. Then this is constant returns to scale. And finally, this is decreasing returns to scale. Okay, third stage, you have decreasing returns to scale, where the efficiency goes down. I think you have gotten better understanding of the notes now. Is there any question? I think we can end here for today.